time, so it wasn't too bad. Right, we're essentially working on finishing off the chain rule. That's really it. The last part of the chain rule is that we're going to apply the chain rule and we're going to evaluate it at one specific point. So I'll start right off with question 11, or at least my version of it. So we have a u squared plus v squared plus w squared. And u is a function of x and y, which is kind of interesting. They kind of switch places here. The variable v is a function of x and y. And the variable w is also a function of x and y. And you've been asked to evaluate a particular partial derivative. Let's just do one of them. The partial derivative dp by dx. And you have to do it at one particular point when x is 0 and y is 6. So that's really the new piece. And that's probably not going to be a big deal. It's just plug and chug. So we need to find the version of the chain rule for this particular combination of variables. Right, since there's three variables here, this is du by dx. Then you do it with v, dv by dx, and then you do it with w, dw by dx. Are you comfortable with why that's the version that we use in this particular combination, right? The main variable is in terms of uv and w, so that's why there's three of these. The subsidiary variable, right, the x's and y's in this case, are two of them, so we got that one now. Side issue, this is the practical part. I need to differentiate this fellow with respect to uv and w. If I'm going to differentiate this guy with respect to uv and w, would you agree that it needs to be written down as a fractional power? And to find just that one, right? Technically speaking, isn't this its own chain rule? Like Calc 1 chain rule. And you multiply by the power. You reduce the power by 1. And then you differentiate what's inside the brackets, partial derivative, with respect to u, and you get 2u. And then you do some style points. And the negative a half comes downstairs. And to finish off the style points, which is actually going to be helpful at the end, return it to there. So far, so good. Now, I know I'm going to have to do this guy, and I know I have to do this guy. But in your test, you would just write down somewhere at the side, by symmetry. Shouldn't I be able to predict these two? Because this is a symmetric function. We like symmetric. I'm doing the easy bit. I actually think both bits are easy. What is on the numerator for the derivative dp by dv?
That'd be v.
Yeah. And would you agree that this would be w? Are we comfortable about symmetry and, you know, what goes where, right? Totally different world, right? Pretend it's a totally different question, right? And dp by du ended up being ugly square root again. We'll keep that the same. But the top wasn't u. The top was vw. What would the second one get you then?
UW?
when you do symmetry, isn't it sometimes what's not there, which is just as important as what is there? Right. So we got 3 guys. Yikes. This fella is the first one, so it's U, and I'm just going to do ... so I don't have to write that, okay? So that represents a square root in the bottom, right? Those are your little dots. Now, if you differentiate this with respect to x, you get e to the y. And the second one has got a v with the same ugly square root, and dv by dx gets you that guy. And the third one is this fella, and dw with respect to x. Ooh, be careful. If you differentiate e to the xy with respect to x, you do get e to the xy, but what also do you get?
Y.
You get an extra y. Now, I'm looking at what we have here. I could probably pull this thing out as a common factor. And that would leave me with this guy plus this guy plus this guy, right? I'm just trying to make it pretty. You agree they all contain the same fella, so I can pull that out. And I'm left with U with this guy, V with this guy, and W with this guy. Are we good? Now that would normally be the end of this question, but we have some extra work to do, which is basically this fella. So what you're going to do is you're going to go and you're going to replace every X, Y, U, V, W, run short of letters of the alphabet here. Where's that come from? It's a square. That's better. So let's see. When X is 0 and Y is 6, U ends up being nothing, e to the 6, which is just nothing. V ends up being 6 e to the 0, which is just 6. And W ends up being e to the 0, which is 1. And so let's figure out what this guy is equal to. He's 1 over the square root of nothing squared plus 6 squared plus 1 squared. U, which is 0 times e to the y, which is 6, plus v, which is 6, y, which is also 6, e to the 0, plus w, which is 1, y, which is 6, e to the 0 again. So 1 over square root of 37, that's nothing. That's 36. And I believe that's 6. So I get 42 over the square root of 37, which probably would work. Or it might be that. Now, provided, which is a guarantee knowing me, provided I did all these calculations correctly, would you agree that's the process, right? So the answer would be what you get. Are we good? Well, there's not much left. Let's see what we got in an interesting than the last couple. Oh, that is a good one. Yeah. Which one do I want to do first? I'll do 12. Well, in case I forget, I'm going to go over one of the practice final questions at the end. So I'm just reminding myself, so I will do it. This is our main function n. It's in terms of p and q. I'll put a little wall here. P is in terms of u, v, and w. And Q is in terms of V plus UW, and R is in terms of W and UV. So basically 3 variables, and each of these 3 variables are in terms of 3 variables. So there's a lot happening here. And we're also being told that we're going to evaluate it at U equals 5, V equals 6, and W equals 4. So that'll happen later on. And we're being asked to find 3 of them. So which one should I pick? It really doesn't matter, does it? Let's do V.
Don't you mean either P, Q, or R?
What here?
Yeah, don't we need to take a partial derivative to P, Q, or R to get to the U or V later? Or am I completely? Okay.
No, you're right. But that is not what they're asking for. I should look at this carefully. Oh, we can still do it. They sneaked this one up on me. Normally you would do P's and P's that then turn into these guys, but you can actually do this one. I'm just looking at what they did there. Let's see why that works. That's a very unusual way of doing the chain rule. Normally, quite right, that's what I thought was going to happen as well. They'd ask you a deep, I can't even say it today. They'd ask you for one of these, right? That's what you would have expected. That's what I was expecting. But they didn't. They asked us for this guy. Now, let's look at why that works. Well, if you look really carefully, I know it's not truly cancelling, but isn't this the contribution that P makes to the answer? This is the contribution that the Q makes to the answer, and this is the contribution that the R makes to the answer. And we can actually find these 3 things, can't we? So it's not typical for a chain rule to do it. In fact, I'm surprised I put that question in, but now I've seen it, I kind of like it.
I'm missing how this is different from the previous problem.
No, actually, it's not. My mind just was going the wrong direction on it.
Right. Okay.
We're
But you
still
can
doing good.
You can still do it, yeah, right? But my mind was in the same place, so I don't blame you. Okay, so, oh God, this is going to be side issues. We have to figure out, putting brackets around these, how to find dp and dn by dp. Would you agree that it's going to be a quotient rule? Now, I'm not going to dwell too much on this, but it's f dash g take away fg dashed over g squared, which is fine. All we have to do is remember p is the only variable in town right now, so that's 1. Leave the bottom alone. Take away, leave the top alone, and differentiate the bottom, which also is 1. And the bottom gets you that guy squared. So that's p plus r, take away a p, take away a q, all over p plus r squared. And it looks like I get that guy. So this fella here is r take away q over p plus r squared. Now, if you do this guy's derivative with respect to v, That doesn't count, and that gets you W. Now, each time I do this, I have to go back to this fella. Only this time I'm going to get the Q guy. That partial derivative. Now, when I look at this question, I don't really need to do this as a quotient rule. Actually, if I did do it, it would still work. Just one of my answers would be 0. Would you agree that bottom is 0 when you differentiate it, right, with respect to Q? Agreed? Right. But if I want to just make my life easy, isn't this a bit like 7 plus Q over 42? So isn't the derivative of this just the bottom? So if you want to look at what the derivative of this is, it's that guy. Now, if you don't like how I figured that out, let me try and show you a little bit more algebraically what I did. Since I'm only interested in this guy, everything else is a number. So I could split it up like that. And now if you find the derivative with respect to Q, doesn't that get you 0 because there isn't any Q's in it at all? And couldn't you think of this guy as that? So when you differentiate it with respect to Q, you get that. Have I convinced you that this derivative is that? Now, you could do the quotient rule, right? And if I did do the quotient rule, essentially what would happen is that one of these guys, I believe it's this one, is a 0. And you get a P plus R over a P plus R squared. They cancel down 1, and you're left with that fella. So it still would have worked. So I have a 1 over P plus R. Now dq by dv is 1. And then I have to do, oops, back to this guy again. I have to do that version. Now I already know this fella. Right? Which one am I looking for? I'm looking for this guy now. Who else do I know? I know this fella, right? So this one here is going to be treated a little bit differently as well now. So let me just pretend I haven't written all those other guys down again. Now, there's only one place where the R is. It's on the bottom. So I could call this guy that fella, which means if I want to find the derivative with respect to R, I could multiply by the power, reduce the power by 1, and then times it by 1. In which case, I could get that. Or I could do the chain rule. And if I did, I would still get that. So I'm just trying to show you, sometimes there can be more than one way to skin a cat, right? You might choose to do a quotient rule for all 3, and the quotient rule will work. Or you might see some shortcuts and decide to go that road. So this fella here is negative P minus Q over P plus R squared. And dV, the R by dV is this fella, so it's times a U. Okay, I'm kind of over this question now. Wouldn't you plug U equals 5, V equals 6, and W equals 4, and that would get me the values for these numbers? And wouldn't I just replace every R, Q, P, W, V, U by whatever they're equal to? And this would be a big messy fraction. that you'd add together and get your answer. And according to them, I'll take their word for it, it's negative 20 over 441. Are we good?
I have a quick question.
Yes.
To clarify, because I'm still wondering, when we get the W, the 1, and the U, we're just taking the, like, was it the partial derivative of when, like, P equals U plus V, we take the partial derivative of just dV, and that would just give us W, correct? Or am I thinking this wrong?
Not sure what you're thinking, so I can't say you're wrong for
I'm
sure.
trying to figure out how we got the W, like the times W, and then the times 1. And then the
Oh,
times
okay,
U.
right, I got you. Right. This piece here, the partial derivative of P with respect to V,
Mm-hmm.
right, I'm going up there, and I'm differentiating this expression with respect to V. So that counts as 0, and that VW, when you differentiate it with respect to V, you get the W left over.
Okay, so, okay. Alrighty then.
Right. And this one came from the middle guy with respect to V. And when you do respect to V, doesn't that get you 1? And that counts as nothing. So you got 1. And then the last one was what? V, that doesn't count, that's 0. And this gets you the U.
All right.
Does. Okay.
Yep.
We are fairly shifting. Our last question. Our last homework question. And it doesn't even have a substitution at the end. So we are just going to find the partial derivative. And X is only a function of T, and Y is only a function of T, and Z is only a function of T. So this is a chain rule where the main function is in terms of 3 variables, and the subsidiary variable, right, in this case, it's just 1, it's T. And we are only going to be asked in a question like this, why is it dW and not delta W by delta T?
Because they're all in terms of T.
Right. If I wanted to, which I don't, couldn't I plug all of these in here and just convert that into W as some ugly function of T? Right. Now, it doesn't really change that much, but you're going to differentiate partial derivative with respect to X, dx by dt, the partial derivative of W with respect to Y, dy by dt, and the partial derivative of W with respect to Z, dz dt. Now, if you're being really lawyer-esque about it, have you noticed that some are deltas and some are d's? These are deltas because aren't these partial derivatives where there's more than one variable? And these are solid d's because in this case, if you differentiate X with respect to T, isn't that a good old-fashioned normal derivative? So it's a normal solid D that gets used. Side issue. I think I chose this question because of algebra. You know, I could just jump straight in and try and differentiate that. Do you know you would make your life a misery if you did that? Right, you would just make your life a lot harder than it needs to be. Can anybody think of a different way of writing that information?
Can you, Ellen?
All right, I hear Ellen, I didn't hear anything else. What else did you say?
1/2 Ellen.
So the 1/2 before the ln and then everything inside.
Yes. Do you see why that's correct? Can you understand where that's coming from? And because isn't a square root a half power, and can half powers be brought out? Now, most of the time, don't we take things that are outside logs and stick them back inside? Because that's what style points is about. But can you see in some respects, in this respect, is one of them. It's actually quite useful to do that. And do you also notice that this is a symmetric function? So wouldn't that reduce our workload as well if we notice that? So I'm just going to find the first one, which is the partial derivative of w with respect to x. And this is a good old-fashioned kind of chain rule situation. It's 1/2. The derivative of a log is 1 over the thing times the derivative of this with respect to x. And something really pretty happens. I think it's really pretty anyway. Isn't that quite nice? Now, can you imagine trying to do it in the form that it's here?
Can you see how much?
Yes. Can you imagine the extra difficulty that would be involved? Because it'd be what, a chain rule of a square root of a chain. Oh God, it'd be messy. Since it is symmetric, and then just put by symmetry somewhere at the side. And we're halfway done. If you do this guy's derivative, he's x over, I'm just going to go dot, 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 so I don't have to write all this again. Multiplied by the derivative of this with respect to t. So what's that going to get me? 6 cosine t's. Plus y over dot, dot, dot. And the derivative of this is -2 sine t. Plus z over dot, dot, dot. And this guy gets me 3 secant squared t. So I could probably bring it out as this is a common factor. And just have 6x cosine t, take away 2y sine t, plus z and 3. So that's 3z secant squared t. And I'd pretty much call it a day. Taylor's on issues getting in, so let's look at that darn question that I want to show you, and then pretty much done for today. Let's see if I can find it. No, that's not it. Go away. Let's see what other windows I've got to play with. I got this window. That's good. And 163. Go here. Right. Almost ready. It's just loading up the PDF. I'm going to put it on the full screen. Let me try and make it as big as I can. I guess that's the big as I can. Right, I'll switch over. I hope I'm right with the answer. I'm always kind of worried. Right, you should be looking at question 11, multiple choice, practice final, okay? And it says here, imagine that you are in this right-hand Cartesian grid. That's just a fancy name for that picture. And you're at the point with coordinates 1, 3, 2. You're standing upright and you're facing the XZ plane. And then you walk 3 forward. You then turn left and you walk 2 forward. what's the coordinates of your final position, right? So this is not a typical question, which is actually what I kind of like doing on multiple choice. So that was the question. Let me try and show you my drawing, what it would look like. So here is X, here is Y, here is Z. Now the point 1, 3 takes me to here, and then you go up 2, takes you to here. So here is the point with coordinates 1, 3, 2. Right, so you imagine that little point floating in 3D space. Now you're standing upright. So there you are, right? And you are facing the XZ plane. The XZ plane is that wall. Can you imagine facing it? So try and imagine yourself in the 3D world, right? You're at this point with coordinates 1, 3, 2, and you're vertical, and you're looking at that one.
The XZ plane was the y-axis.
No, that might be your confusion. The y-axis is just the y-axis. The XZ plane has a y coordinate of 0, which might be what you were thinking. Does that help? Right, so let's continue our journey. What colour pen? I've got purple now. You move 3 units forward. Do you notice that if you move 3 units forward, you'd hit the wall, and your location, right, would be 3 off that number. So you would now be at position 1, 0, 2. Can you visualize that? You're walking and you hit the wall. Now, when you hit the wall, you then turn left. So if you turn left, you're pointing that way, right? And you move forward 2 units. Okay. So when you move forward 2 units, won't you be adding, actually my picture's not great because the dot would be here. Shows you why doing things in 2D is not a good idea. You'd still be hitting the wall, right? But it would be there. And that has location 1, 0, 2. If you think about it, it makes more sense anyway, doesn't it? Right, move 3 forward, 1, 2 forward, I should say. And that will take you to here. And here is position 3, 0, 2, which I believe is D. Kind of like questions like that, even if you don't. It's just a little different. Have we got any more questions? Because we're kind of finished. So what's going to happen in the next 2 days is you are going to be really prepared, and you're going to bring good questions to ask me about homework questions, about things that are going to happen in test 4, about things that you've noticed in the final, or things from week 1 that you've forgotten about, whatever. And I am more used to you if I answer your questions than if I just randomly pick topics I think you might or might not need help on. So it's much better if you can, you know, do it. It's also helpful tomorrow if you make your questions a little bit specific. So if I say, Noah, what do you have problems with? If you just say everything, it doesn't really help me much, right? So you try and nail it down a little bit and say, I'm still having trouble with chain rules. Those questions we did the last section. Or, I don't know, how do you get that binormal thing? That's a real pain in the butt. I've never figured out how you do it successfully. Something a little bit more specific, and we can do that. Okay, say hi, everybody. I'll hang about for the usual questions for those who have them. and I'll see you tomorrow.
I just had a quick question on what day is the final?
The final, I'm going to get this wrong again. Douglas, it was Thursday. Tell me
It
it's
is
Thursday.
Thursday.
It's Thursday.
But
I checked my syllabus and it says Thursday, the online syllabus, not the printed syllabus.
on the practice exam, it says our test is from 10 to 3. I thought it was 10 to 1.
That's a typo.
Yeah.
Yes, it's a typo. But thanks for telling me it because I'll put it in.
Yeah, because I think a lot of students might think that it's 6 hours instead of 3.
Oh God, no! Nobody wants to do. No
Yeah.
one wants to do 6 hours of anything. So yes, it's Thursday and it's 10 to 1.
Got it. Thank you. Have a good day.
You too. Right. As soon as we leave, I'll go in and fix that. So anybody who drops in doesn't. Maybe that's what made Kathy's hair go white. That wasn't very nice. From someone who's got virtually no hair, I should talk about people's hair. Right. Any questions from anybody? Jocelyn, are you actually with us? Because you were popping in and out a lot today.
Yeah, it's the 18th. It's Thursday. Yeah.
I had a question.
Right. Who's got a question then? Who wants to start?
I was wondering if you could go over number 6 from the homework on 14.3.
Let's hold on. I thought I read it down. So it's 14.3, number 6. Is it something you can read out, or will I have to go look?
Yeah, I can read it out.
Okay.
The equation is f of x comma y equals ax plus by.
Oh, AX.
Yeah.
Oh, is it the AX plus BY over CX plus
Yeah.
DY?
I
know that
tried
one.
doing it like 3 different ways and I kept getting the wrong answer. I got all the other ones right, but this one.
Right. So what is this the partial derivative with respect to X or Y, or is it both
Yeah.
that you're having trouble with?
It's x and y.
Is it X or Y or both?
X.
Okay, so let's do X. Then what I'm going to realize here is this is a quotient rule. So it's going to be f dash j, take away f of j dashed all over g squared. What makes this a little bit different from the typical questions is that there's these extra guys, A, B, C, and D. You see them? Those are also constants. So I'm treating them like numbers as well. But these are a little bit different in the sense they are always constants. They're never going to be regarded as a variable, right? X and Y, depending on the question, is considered a variable or a constant, right? X and Y are. But A, B, C, D, they're all called constants forever. So if you do the top one with respect to X, all you get is A. Because that's like 42 times 2, but it's still a number, so its derivative is 0. We could go with that one.
Yep.
Leave the bottom alone. Leave the top one alone. And differentiate the bottom with respect to X gets you C. And then square the bottom. Now distribute. ACX, add AD.
Wouldn't that be ADY?
No, there's no one.
There should be a y with the d.
Well, let's check that. You're right. You're right. Take away ACX, take away BCY. All over CX plus dy squared. They kill each other off. So I have an ADY, take away BCY. Over that guy. I probably pull out a common factor because it is there.
Yeah, so when I put that in WebAssign. It said I was wrong.
Okay, let me go and see specifically what WebAssign was doing. This was in 14.3.
Yep.
Where the heck is 14.3? Oh, it's out of sync for some reason. Okay, so I'll go into scores. What was it? It was Damien.
Yeah, it's possible I mixed up a variable or something, but
I'll check it out. Doesn't take long. Question 6. There we go. Yeah. Yeah, the answer I have got is the one that they have. The only difference is they stick a Y at the end. But that, I don't think that should be an issue.
okay, I'll try it again then. And see.
Right. Okay. The answer that I have here is just a simple fraction, so we know that's not right. And there's no cancelling really, except pulling out a common factor. Okay, any other questions?
Yeah, I have a quick one.
Yeah, what you got, Douglas?
So for number 12, it asks which of the following statements is the only one which is true, and the true
Yes.
one is the vector v 1 over the square root of 3, 1 over the square root of 2, and the negative 1 over square root of 6 is a unit vector.
Right. What number was that again?
Number 12.
Number 12. Okay. So it's which one is the only one that's true, and the vector v is a unit vector. Let's see, that's a third plus a half plus a sixth, and that is true. So what's your question?
I thought, how do we, maybe I forgot.
Well, what you need to do with vector v here is find its length. And if its length is 1, it's a unit vector. Well, remember what you do, you take the x component and square it, plus the y component and square it, and the z component and square it, add them all up inside the square root. So what you end up is 1/3 plus 1/2 plus 1/6.
Minus
And that's
1/6,
up to, well, when you square it, it'll be a positive. So it'll be plus 1/6. And that adds up to 1, and the square root of 1 is 1, so it is a unit vector.
Oh, okay, I see. Thank you.
Now, since there's only one correct answer, if you see an answer that's right, stop looking. It doesn't matter, there won't be 2 right answers, right? There's only one that's true. And so that's it. Sometimes the question is which one is the only one that's false? Well, you just find the one that's not true and stop looking when you found it, right? So that's just a piece of advice. When you do multiple choice, if you found the right answer, stop working. Just put the letter down and move on. Another thing you can do sometimes in multiple choice questions is, if it has to be one of 4 answers and you've done 4 and you know it doesn't work, do you know it has to be the last one? So you don't even need to prove that it's the last one. You know, if it says which one of these is the only one that's true, and you've done 4 of them, and every one of the 4 that you tried were wrong, right? They're all false. Then the one that's left has to be true, even if you don't know how to prove it's true. It must be true anyway, because it's the only one that's left. So that's just another tricky multiple choice. And sometimes in multiple choice questions, out of the 5 answers, there might be a couple that are so stupid that you won't even try them because you know that ain't going to work. And you just focus on the ones that are more likely to reduce your workload. It's all about reducing workload, right? How can I stop from having to do everything, the long way? Right, next question, if we have one at least.
Yeah, there was one where it included a
Do you have a number for it?
yeah, I'm trying to find it right now. I was trying to work on it. It had a oh, it's number 3.
Okay, let me switch over to the test so everybody can see the questions that we're talking about. The practice final, I should say. Is it section 2 or section 1?
Section 1.
Okay, so it's right at the top here somewhere. Right. Which one of the following statements about this sequence here? Can I make that bigger? Right. So only one of these statements is true. Right, you see this guy here? Right. Can you trust me that you can do L'Hopital on it? And if you do L'Hopital on it, you end up with a remarkably nice answer. It ends up being negative the cosine of 1 over n squared. You can then make n go infinite, and it ends up being negative the cosine of 0. And cosine of 0 is 1, so it ends up being negative 1. So that's why the answer is C. So you have to do L'Hopital's rule
Wait.
on 1 minus the sine of 1 over n squared over 1 over n squared.
I think it said the answer was D.
It did. Well, let me double check.
Canceled in your mind when you shouldn't have, because you're doing L'Hopital's to both the top and the bottom.
Right. Well, let me check it out in case I've given you the wrong letter, because I like -1 and I want it to be true. So if it's not -1, it must be because it diverges. It is a sequence. So let's just check it out. So I'm going to find the limit as n tends to infinity, because that's what you do when you want to find out if a sequence converges. And the sequence happens to be 1 over the sine of 1 over n squared all over 1 over n squared. Now, according to L'Hopital, what do I get? Well, if you differentiate 1 over n squared, can you trust me you get -2 over n cubed? But you can check it out. If you differentiate that, you get 0. If you differentiate this, you get negative the cosine of 1 over n squared times the derivative of 1 over n squared, which is this fella. But this fella cancels with that fella, and we now have the limit as n tends to infinity of negative the cosine of that, which I can do as brute force. And the answer is C. So I have to fix that because it should have been C. Don't know what I did wrong.
So it does converge to -1.
Wait, so, oh yeah, never mind.